Good morning, ladies and gentlemen, or good afternoon, whatever the case may be. This is going to be a very short video. We're going to talk about vectors 101. We'll use these vectors when we start talking about parametrically defined positions and parametrically defined velocity vectors. But we first need to talk just about what a vector is. A vector is a line segment. It is a line segment with specific direction and specific magnitude. The magnitude is the length of the vector. The magnitude is the length of the vector. The direction is the smallest positive angle formed with the positive x-axis and the terminal ray. And I will demonstrate that here in a moment. Vectors are usually denoted by a single letter with a ray on top. Make no mistake about it. This is not a ray. A vector is not a ray. A ray goes on infinitely, and a vector has an initial point and a terminal point. So we will be looking at, now this is a notation for a vector, but we're going to be looking at vectors in component form. And in component form, you can see this funky little parentheses 2, 5. So that's going to represent this vector. It's going to be pretty easy to understand this. Oh, 2 over 2, 1, 2, 3, 4, 5. So that's the terminal point. But what we want to do is we're going to create what may appear to be an array, but it's not. Bam. And so that's the component form. That's the vector 2, 5. Keep in mind it stops. This is just denoting, the angle is denoting which direction that vector is going. And this angle is the direction, and we will find that angle. And keep in mind, what is this terminating point? The terminating point here is 2, 5, because we still are in XY land. And in fact, before I show you how to find the magnitude or the direction, if I click on that rascal, let's see if I can click on it, copy, and then paste, and paste again. So I can take these particular vectors and put them wherever I want in the XY coordinate plane, and they're going to be the same vector because they have the same magnitude, which is the length, in the same direction. All of those guys are parallel. We will look at some vectors who have an initial point other than the origin, but we will always mostly speak about vectors. This vector 2, 5, the initial point is the origin on the xy axis, and 2, 5 is the terminating point. But keep in mind, these vectors they're the same vectors. They're the same vectors because I can translate that vector and to be right over that. So those are absolutely the same vector. So let's just get these guys out of there. Delete that rascal and delete this guy. And delete this dude right here. Okay, so the first thing that we're going to do is we're going to find the magnitude of that vector, i.e. the length. And in order to do that, do not make this more difficult because it's pretty straightforward. What we're going to do is just look at this right triangle here. And we pull that out, that right triangle out. I think it's clear to see that this distance right here is 2. And this distance here is 5. That's clear. And so now if I want to find the magnitude, we can let this be anything. We'll just let it be c. And I know that c squared is equal to 2 squared plus 5 squared. So c squared is equal to 29. And c then is equal to the square root of 29. And that is the magnitude of vector v. So magnitudes are going to be very important because we're going to find magnitudes of velocity vectors. The next thing we want to do here is to find this angle here. Well, we want to find this theta. And just to make it easier, we're just going to let for these particular exercises, I think most of the time the angles that we're going to find are going to be in degrees. So I'm going to make sure that my calculator is on degree mode, and this is the angle that I want to find right here. This is the theta. Well, what do I know? Well, I know that tangent of theta is the opposite over the adjacent side, and then simply theta is equal to the inverse tangent of 5/2. And I'm going to take my calculator. I'm going to find out what that rascal is. Here we go. I'm going to go inverse tangent of 5/2. I was in radian modes. I'm going to try it again because I want to keep it in inverse tangent of 5 divided by 2. And that's about right. So theta here is equal to, putting this into my calculator, is 68. We'll round to 2 decimal places here, or to 1 decimal. 68.2 degrees. That's theta. So that is the direction that vector going. So that vector, the component form vector 2, 5, has a magnitude of square root of 29, and it is going in the direction of 68.2 degrees. Okay, well, let's go for another example. I'm telling you that this vector stuff is pretty easy. We will use it down the road quickly. All right, so let's plot the points. Here's example 2. Let's plot the points -1, 4, starting at -1, 4, and ending at 2, -3. We're going to find the component form of the vector with the above endpoints, being sure to start with the first point given, and then we're going to find the magnitude of that vector, and I think we're going to find the direction of that vector too. So let's go ahead and plot these points. -1, 4. -1, 4 is going to be here. -1, 1, 2, 3, 4. That's going to be -1, 4. And now I'm going to go 2, -3. 2, -3. 1, 2, 3. And keep in mind, I started at -1, 4. So that means my direction, my arrow, this is going to be the end point. An arrow would be a good way to look at it because an arrow has finite length. So let me zoom out here and get everything in there. I'm going to go to my ray tool, and this is that vector right there. This is that particular vector that has starting point, initial point of -1, 4. Initial point -1, 4. And terminal point to -3. So I need to find a way to find the component form of that vector. And it's pretty daggone easy if you think about it. If I took and translated that vector to where the starting point is at the origin, I'm not going to change its direction, nor am I going to change its length. I'm just going to grab that rascal and translate it until the starting point is at 0, 0. And now I want the component form of that vector is going to be whatever coordinate this is right here. Looks like it's going to be 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. So the component form of that vector then is going to be 3, -7. That's the component form of that vector. And if you look very carefully, whoopsie, another way you can find the component form is if you notice, if you just take the x coordinates and subtract them, like what is 2, let me get some pen here, what is 2, it's not the one I want, 2 minus -1, subtracting the x components, that's going to be 3, and I have -3 minus 4 is going to be -7, and that's the component. Those are the coordinates of the component form of that vector. You can do it that way, or you can just kind of or you can count. You could have just counted how far over do you go from here. You go 1, 2, 3, and then down 1, 2, 3, 4, 5, 6, 7 to the red point. So now let's find the magnitude of that vector, and the magnitude of that vector is going to be pretty straightforward. We're going to let the magnitude right now, we're just going to, and all we're really doing is using the Pythagorean theorem. So let's c squared equal 3 squared plus, and we're just looking at the triangle, so we can just go 7 squared. We could do -7 squared, but we're just looking at the triangle because we want this length. And so I've got 9 plus 49. And that's going to be 58. So c squared is equal to 58, and c is equal to the square root of 58. And that's the magnitude of that vector. Now, to find the angle, what we want to do is find this angle right here. Positive angle that starts at the positive x-axis and sweeps around. Positive angle, meaning counterclockwise. Well, what I'm going to do here is I'm just going to find, you have to be, just think a little bit here. I'm going to look at this triangle right here. And I know that this length right here is 3. And this length right here is 7. So I'm going to find this angle here, alpha. And once I find alpha, I'm just going to add it to 270. So what do we know? Well, we know that the tangent of alpha is equal to what? Opposite over adjacent, 3/7. So therefore, alpha is equal to inverse tangent of 3/7. Let's figure out what that is. Go to my graphing utility. Inverse tangent of 3/7 is going to be 23.2 degrees. So alpha is 23.2 degrees. But what is the direction of that vector? The direction of that vector is going to be theta will be 270 plus that 23.2 degrees. Which is 293.2 degrees. That's the direction. So the direction of this vector right here is 293.2 degrees, and the magnitude is square root of 58. I got to tell you, ladies and gentlemen, this was a very brief lesson about vectors. And how are we going to use that in calculus? Well, we're going to use that in calculus because we're going to look at velocity vectors, and we're going to find the magnitude of a velocity vector. And that's the only reason where we're going to use vectors in calculus, in parametric calculus. So I hope you watched the video, and we will see you soon.